I'm Caroline. Reacting mass calculations can feel so confusing, but really it's just combining what you already know, mole calculations and molar ratios. In this video, we'll walk through how to calculate the mass of a product or reactant in a chemical reaction using clear steps and practice questions. You are going to feel so comfortable and confident by the end of this video. Subscribe right now if you're finding these helpful, and let's dive in now.
Let's start off with why this is important. What is the point of a reacting mass calculation? Well, the idea is we use it to find out how much reactants we need or how much product is made. So if you're a chemist in industry, you might want to know how much of stuff to add in or how much you're going to get out. So that's the point of these calculations. Quick reminder, you're going to need to use a couple of skills we've met in previous videos. So that is calculating moles and using molar ratios. So if you're thinking, what is that? Head back to those videos now and I'll talk you through each of those skills step by step. So the equation that we're going to use is mass over Mr. Moles, or if we rearrange that, moles is equal to mass divided by MR. Mass is always in grams, by the way. The method that I'm going to talk you through, I'm going to summarize by these 4 steps. And pretty much all of the calculations across GCSE and A-level, especially for AQA syllabus, follows this kind of method. You can use it all the way through. So I will talk you through it now, but really when we go through the guided examples, that's when it's going to make the most sense. So the first step is always to assign a tick and a question mark. And what that means is the tick is something that the question tells you about. So the question might say, we have 10 grams of oxygen. We have 24 grams of magnesium oxide made. So if you know something about one of the substances, that is our tick. The question mark is, what is the question asking us about? Is it how much ammonia is made? Well, then ammonia becomes our question mark. Is it how much oxygen is required? In which case, the oxygen is our question mark. Then we're going to work out the moles of the tick. Once you've done that, and only at that point do you use the molar ratios, the big numbers all the way across the equation, to work out the moles of the question mark. And then finally, we use that to work out the mass of whatever it is the question is asking us about. So let's look at this in practice. I'm going to talk you through several examples. If you'd like to have a go ahead of me going through the workings, then just hit pause and then come back when you're ready for the answer. So the first thing we're going to do here is figure out what our tick and our question mark is. That's the first step in our method. Now we know we have 14 grams of lithium. That becomes our tick. We are asked to find out something about the oxygen. That becomes our question mark. We're now going to set this up as a table. So we're going to take down this left-hand side, mass, Mr. MR, and moles. Always in that order. Mass is equal to Mr. Moles. Now we're going to fill in what we know. So starting with the tick, this is step number 2, moles of the tick. We know we have 14 grams of the lithium. We can work out the MR from the periodic table. There's just one of it, so it is 7. You do not use the big numbers at this point. The MR of lithium is always 7, no matter what big number is in front of it. In order to work out moles, its mass divided by MR is equal to moles. So 14 divided by 7 is equal to 2. Now we're going to switch column, and this is the only point at which you're going to use the big numbers. So in front of the lithium is a big number 4, and in front of the oxygen there is no number, which means it's a 1. That means the ratio here is 4 to 1. I'm going from the 4 to the 1, so therefore I'm going to divide by 4, which gives us 0.5. Now we're going to work up the column. So in order to work out the mass now of the oxygen, we find out the MR of the oxygen. So that's 2 times 16 is 32. We do the 32 times by the 0.5, and that gives us an overall answer of 16 grams. Don't forget units at that point, but that's your answer, 16 grams. Let's start with the tick and question mark again. Now we know we have 20 grams of hydrogen. That is therefore our tick. We know something about it, 20 grams. The question is asking us to calculate the mass of ammonia, so we put the question mark over the ammonia. It means we can ignore this nitrogen in the middle completely now. Let's work down the first column, the hydrogen, that is our tick. So to work out the MR of the hydrogen, look at the periodic table. It has a mass of 1. We have 2 hydrogen because it's H2, so its MR is 2. To work out the moles, it's mass divided by MR equals moles. So therefore 20 divided by 2 is 10. Now this is the only bit that might get tricky now. We're now going to swap columns over to our question mark. So if we look at the big numbers now, we have a big 3 in front of the hydrogen and a 2 in front of the ammonia. That means that is a 3:2 ratio. Now, the easy way to convert between these ratios that are a little bit trickier is divide by the first number times by the second number. Because 3 divided by 3 is 1, times by 2 is 2. So divide by the first number times by the second number. That gives us 6.667. I'm going to keep as many of the decimal points here as I can, because otherwise our answer could end up with a rounding error. So don't round at this point. Now we're going to work up the column. The MR of the ammonia is 17. That's 14 from the nitrogen plus 3 lots of 1 from the hydrogen. In order to work out the mass, we do the 17 times by the 6.67. That gives us an overall answer of 113 grams, not forgetting units. So same method, starting with the tick and question mark. Now this time we know something about the oxygen. We know its mass. That's our tick. We're asked how much ethanol is burned. So therefore, that's our question mark. Now let's start with the tick. Now we're told we've got 100 kilograms of oxygen, but kilograms is not the standard units for mass. We have to convert that into grams by timesing by 1,000. So 100 times 1,000 is 100,000 grams. Now divide it by the MR. We have O2, so 2 lots of 16 is 32. Do 100,000 divided by the 32, that gives us 3,125 moles. At this point, to switch columns, we're now going to use that ratio, so that's the big numbers. The big number in front of the oxygen is 3. The big number in front of the ethanol, there's no number there, which means it's a 1. So we are going from a 3 to 1, so we are dividing by 3. That gives us here the number of moles of ethanol of 1041.667. Now again, try and round it as little as possible as you can. So in this case, I suggest keep the whole number in the calculator and just write down a smaller number of figures. Now working up the column to find the mass of the ethanol. To work out the MR of the ethanol, we do 2 times 12 for the carbon, plus 6 for the hydrogen, plus 16 for the oxygen. That is 120. In order to find out the mass of the ethanol, we do mR times moles, and that gives us 125,000 grams. That's your overall answer. So here's a few common mistakes to be aware of. First of all, if the question is asking for mass, so the answer is calculate the mass of, etc., don't forget units. Don't forget units. Don't do all of the hard work and then miss a mark by just forgetting to put units on your end answer. Remember, for mass, the standard units are grams. If they are not in grams, you need to convert into grams. That's our next point. So you have to put your mass into those standard units, grams, before starting the calculation. And that means even if you get to the right answer, if you didn't do those unit conversions first, then the question would still be marked wrong. You don't get full marks just from having the correct answer, because the number of moles will be incorrect throughout. And 1 dozen is not the same as 10 dozen, for example. So 1 mole is not the same as 10 moles. So before you start any calculation, put what you need into standard units. In this case, it's putting whatever mass you are given into grams, and then work it through from there. Make sure you're showing your working. So chemistry is not maths, which means every single number has a meaning. Let the examiner know that you know what that meaning is. So don't just bang your numbers down. Right next to it, moles of ammonia, moles of oxygen, whatever it is, so that a number always is clearly shown as what it means. The way I've shown you as a table will sort that out for you, because reading along, you can clearly see what those numbers mean. And then finally, only use the big numbers, which are the numbers in front of the substances in the equation, when you are switching columns in the table. Never use those big numbers when you're calculating MRs. So for example, the MR of water is always 18, 16 plus 2 lots of 1. It doesn't matter if I have 2 waters, 4 waters, etc. The mass of the water stays the same, it's 18. Your big numbers, that's used for balancing the equation. That is for switching column and working out the moles of anything else in the equation.
Thanks for watching, and if you found this helpful, don't forget to hit subscribe now so you can tune into new GCSE and A-level chemistry videos every single week.